Okay, so this is the first of the Ed Puzzle problems from the quiz. There'll be three of these videos. So the national SAT score is, average SAT score is 1006. Reagan High School counselors feel that their students are performing above the national average. The high school counselor chose 40 students at random and found their average SAT score was 1120 with a standard deviation of 25. So we have a sample of size 40. Probably should note that down. We ended up with a sample average of 1120, and we have a sample standard deviation of 25. Because I have a sample standard deviation, I need to see if I can use the t-distribution. Right? Because the standard deviation sample, that lets me know that I work with the t-distribution. So I'm going to go ahead and figure my degrees of freedom, which is 40 minus 1, or 39. Is there evidence to support the high school's hypothesis that their scores are above the national average at a significance level of 0.01? So my alpha level is 0.01 that I'm testing at. All right, so on the recipe card, the very first thing it asked me to do, since they're talking about testing, this obviously is going to be a hypothesis test, and so we need to write our null and alternative hypothesis. The null is always going to be HO. The alternative will be right below it. And since we're talking about means, mean average, we know we're talking about a mu, and I don't draw a very good mu, and the null is always going to be an equal sign every time. So what is the standard course? What is the status quo? What are things assumed to be? And what are we making a comparison to? In that case, it's 1006. And I'm going to say that's SAT score. All right. Now, the alternative, mu and 1006 aren't going to change. I just need to find an inequality to drop between them. And it's either going to be a less than, greater than, or a not equal to. And in this case, they say above, so that means it needs to be greater than 1006. So we're looking for, that's our alternative hypothesis. Next thing we need to do is define our parameter, which is mu. So let mu equal the true population mean SAT scores for Reagan, because we're not looking at it for the US or the world, we're just looking at it for Reagan High School. And it'd probably been great if I said Reagan High School, but I'm going to try to keep it shorter. So then we have our conditions. The first condition is needs to be a random sample. And it turns out that they say chose 40 students at random. So we're assuming they did it correctly, and they said that it's a random sample, so we're just going to be able to say it's given. N needs to be less than 10% of the population. So we're always going to either divide by 0.10 or multiply by 10, whichever one you prefer. So that equals 400. And there are more than 400 students taking the SAT at Reagan. So our sample is less than 10% of the population. Number 3, normality. And I actually find this one to be really an important one, because we can't do the test if it's not normal. Of course, we can't do the test if those other things aren't done, but you should be taking a random sample. That's just intelligence, and we need to make sure that our sample is not too large. So how do I check normality? If I have data, I'm probably going to have, and if I have data, I may have to do a box plot. I don't have a list of data. That's good. I don't have to do a box plot. They could tell me it's normal. They didn't. In this case, my sample size is 40, which is greater than 30. So the distribution, and by the way, it's not the distribution, it's the distribution of means, is normal by central limit theorem. And you need to make sure you say the distribution of means is normal by central limit theorem. All right. So that satisfies that. The next part says write the equation. Our equation is T equals, I'm going to box this stuff off so it separates it a little bit. T equals x bar minus mu s divided by the square root of n. We need to draw a graph in shade. So our graph is going to look something like this, where we have a population mean of 1006, and that's mu, but we found an x bar, which is above it, which is 1120. And our alternative was shading to the right, so we're going to need to shade to the right. And so we're trying to find out what is the likelihood that we'd get a sample statistic of 1120 or greater if, in fact, Reagan really only has a 1006 SAT score average. All right, so we're going to start plugging in. And so we're going to go probability that x bar is less than, greater than, that's wrong. This is a greater than sign, 1,120. And that's the probability that t is greater than 1,120 minus 1,006, the population mean, 25, which is our standard deviation of the sample, divided by the square root of our sample size, which happened to be 40, because the counselors surveyed 40 students. So we're going to go ahead and run this thing, stat test, and it's going to be number 2 t-test. And mu was 1006. That's the claim. Oh, I need to go up and make sure that data is not highlighted. I need to highlight statistics because I'm actually using the statistics it gave me. So my mean is 1006. The standard deviation that I've been given, the mean of the sample is 1120, because that's what the Reagan students scored on average. Their standard deviation was 25. My sample was size 40. Make sure that that our inequality matches what we have in our alternative hypothesis. And when I go to calculate, I end up getting an incredibly probability that t is greater than 28.839. That is a huge, and we look at this and we go, oh, wow. So we just say that this is approximately 0. All right, and I'm going to check that real quickly. Stat test, t-test. Did I put everything in right? Yes, I did. So we have a p-value of 0. That's very, very extreme. And in other words, it's not happening much by chance. That's not happening by chance or unlikely to. All right, so our p-value, and then our alpha. Our p-value happens to be approximately 0. Our alpha was 0.01. So 0 is less than 0.01. So we're going to reject the null. And we go and write our conclusion. Please use the conclusion on the recipe card. Our p value is approximately 0. We reject the null. There is sufficient evidence at alpha equal 0.01 to suggest that the true population mean SAT score for Reagan, and my alternative was greater than 1006, and that's all our claim is greater than 1006. So what we've done here is we've run this hypothesis test, and we said, you know what? When we ran it, we got a sample mean of 1120. Well, that would indicate that we have some evidence that's greater than 1006. We calculated the probability of that happening, and it's like, gosh, by random chance alone, this just is almost 0. It's really, really tiny probability it happened by random chance alone. That's less than 1%. We're going to reject the null and say that Reagan students score greater than 1006. So defining the p-value in context. Now, we haven't done this in class, but we're going to do it here because at some point this is going to become standard for you guys. You're going to need to learn how to define the p-value in context. And the p-value is the probability that we'd get a test statistic as extreme or more extreme given that the null is actually true. So in this case, there is about a 0% chance, because that's our p-value, of getting a sample mean of 1,120 by random chance if, in fact, the Reagan student average score is actually 1006. So there's about a 0% chance of getting a test statistic this extreme or more extreme, sample mean of 1120, and this should say or more or greater. Left that off because it needs to be as extreme or more extreme, given that their actual score is 1006. So we're definitely believing that the Reagan students score better than the national average. Good job, guys.